Now that we have a new number I, let's try to understand it better. Our definition of I is that I equals the square root of -1. Or another way to say this is I squared equals -1. We'll put this below because what we want to ask next is what about other powers of I? Well, I to the first power is just I. How about I to the third power? This means we have I times I times I. But we know I times I is I squared, which is -1. So I cubed is -I. Let's see if we can do the same thing with I to the fourth. I to the fourth is I times I times I times I. But we can clump the first two i's together as I squared, which is -1, times the second two i's, which is I squared again, or -1 again. So we have -1 times -1, which is just 1. How about I to the fifth? Here we have I times I times I times I times I. But those first four are I to the fourth. So this is I to the fourth times I, and we just found that I to the fourth is 1. So we have 1 times I, which is just I. This means that I to the fifth power is the same as just I. How about I to the sixth? Here we have I multiplied by itself 6 times, which we can clump together the first 4 and the second 2. The reason we do this is that we know I to the fourth is just 1, and we know I squared is -1. So I to the sixth is 1 times -1, which is -1. For I to the seventh, we can break it up as I to the fourth times I cubed. And we know I to the fourth is 1, while I cubed we found to be -I. So we get that I to the seventh is 1 times -I, which is just -I. And for I to the eighth, we break it up as I to the fourth times I to the fourth, which is 1 times 1, so we just have 1. Let's consolidate what we found. I to the first is I squared is -1, I cubed is I to the fourth is 1, then I to the fifth is I again, I to the sixth is -1 again, I to the seventh is -I, and I to the eighth is 1. Notice we're getting a pattern. And if we compute I to the 9th, 10th, 11th, and 12th in a similar way, we'll get what we would expect. I to the 9th is I to the 10th is -1, I to the 11th is -I, and I to the 12th is 1 again. This is because each time we multiply by I to the fourth again, we are just multiplying by 1. In general, if we have two exponents, m and n, then what we get is I to the m equals I to the n if m and n differ by a multiple of 4. For example, I to the 11th equals I to the third, because 11 minus 3 is 8 is a multiple of 4. Or in other words, I to the m equals I to the n if n minus n is a multiple of 4. So we can figure out all the powers of I with this pattern in knowing the first 4 powers. In the next video, we'll look at some examples.